What is going on, guys? Welcome back. In today's video, we're going to learn how to professionally backtest stock trading strategies in Python. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so in order to do backtesting in Python, we're going to use an external module called backtesting. And for that, we're going to open up the command line and we're going to type pip install backtesting. And once we have that, we're going to go into our Python script and we're going to say from backtesting, import the backtest itself and also the strategy. Then we're going to say from backtesting.lib, we're going to import crossover. I'm going to explain that when we use it. And then we're also going to say from backtesting.test, we're going to import SMA, which is the simple moving average. And we're going to import Goog, which is the ticker symbol of Google, of Alphabet, which provides us with some sample data for testing. However, I'm also going to show you later on in the video how we can use our own data for the backtesting. So you don't have to use this Google data here. You can also use Facebook, Tesla, or even some crypto data if you want to. But those are the things that we're going to import now. And the first thing I want to do here is I want to create a simple strategy that is just going to look at two different simple moving averages, and when they cross, we're going to either buy or sell. So this is a very basic strategy, and the topic of today's video shouldn't also be too much about finding the best strategy. It's more about the backtesting. So we're going to create a simple class, and we're going to call it my SMA strategy. This is going to be the name, and it is going to extend it's going to be based on, it's going to inherit from the strategy that we imported above. And we're going to define two functions in here. We're going to define an init function or method, and we're going to define a next method. And the init method is not the constructor. So we're not going to say def underscore init. We're going to just say def init. This is a specific function or a specific method name that is recognized by the backtesting module. And what we're going to do now is we're going to say def init, and we're going to say that the price is whatever the close price of the data is. So we're going to say self.data, and we're going to say from that we want to have the close price. So this works by using the strategy parent class. Because of that, we can do something like self.data.close to get the closing price. And then essentially we just wanted to find the two metrics that we're going to look at. Here we're going to say self.ma. MA1 is going to be self.I. So we use this I function here, and then we pass the metric, which is the simple moving average. Then we pass the price, and then we pass the time window. So now we would say SMA of price and 10. So this would be the 10-day moving average, simple moving average. Now we can copy that and create an MA2, moving average 2, and this is going to be one of 20 days. And our strategy is going to be quite simple. We're going to define the actual strategy in the next function, so in the method called next. And here we're going to say essentially if crossover, this is why we needed that function here, if crossover of the moving average 1 and the moving average 2 happens in that direction, so the moving average 1 crosses the moving average 2, then we're going to do something. So we're going to say if crossover self.ma1 self.ma2. If that is the case, we're going to buy. So we're going to say self.buy. This is the strategy. Then we're going to say otherwise, or actually not otherwise, elif crossover if we have the opposite crossover. So self.ma2 and self.ma1. We're going to say self.sell. Again, this is not for building a trading bot. I have multiple videos on this channel where I show you how to build a trading bot. This is just testing a strategy. So here you define what you do. You get you give it some data, and then it tells you how well this strategy would have performed on the given stock. So this is now our strategy. We initialize the indicators. We use them here. We defined our strategy. So let's go ahead and backtest it. How is this done? We say essentially backtest is going to be equal to backtest with a capital B. So this is the class that we imported up here, and we're going to create an instance of this backtest by passing Goog. So this is the testing data that we imported from backtesting.test, and the strategy that we want to evaluate is the my SMA strategy. The commission is what we have to pay per transaction. This is important. In most brokers, you have to pay transaction fees. So when you buy or sell, you have to pay a percentage to the broker. Let's say this is now 0.002 of commission. And then we're going to say also exclusive orders equals true. And then we're going to say stats equals backtest dot run. And I think by just running that, we should not, I'm not sure if we're going to see the plot already, but when I run this now, you can see nothing happens because we didn't output anything, but we can go ahead now and print the stats, and we're going to see some interesting metrics down here in the output. You can see we have the duration of the whole testing, so you can see from 2004 to 2013. You can also see the return. This is the return that we would have gotten using that data in that time period, with using that strategy in that time period. We would also see here compared the buy and hold return. So if you just buy and hold, this would be your return in percent. And with our strategy, it was less than buy and hold, which is not good because just buying and holding is better than using our strategy, which means that probably our strategy is not that good. What else do we have here? We have the equity final and equity peak. This is essentially what the value would be final, or what the final value of our investment would be in dollars. This is the maximum value, so a little bit more than the final value. And then we can also see the individual transactions. We have a win rate of 54%, basically meaning that when we do a trade, this is the win rate, or across our trades, this is the win rate. And actually, before we talk too much about these metrics here in text form, let's just go ahead and say backtest.plot, because this is going to create an HTML file and also open it up automatically in the browser. And we're going to see here, this is our trading strategy. So you can see here that this is the stock price, and essentially every dashed line that we have here is a trade. And depending on the color, the trade was either profitable or not. So the transparent boxes that we see here in the background, so the green box, the red box, and so on, those are essentially the months. So here we have 1 month, another month, another month, and so on. And the dashed lines are the trades. So the trade here would be buying here, selling here. It's green, thus it's profitable. So we buy here, we sell here. This is a trade, which is profitable. What else do we see here? Essentially, the triangles that we see up here, they summarize the profit and the loss. If the triangle points upwards, that means that we sold. If the triangle points downwards, that means that we bought. If the triangle is green, this means that whatever we did, buying or selling, was profitable. And if it's red, it means that we lost money. So not every line that goes up means that we bought. So for example, here, we sell here and we buy here, which is a loss, which is why we have a red transaction here. So you can see pointing down means that we bought here and we sold here because this is pointing up. So here we sold for a profit, we bought here, we sold here, this is a profit, but then we bought here, which means that we missed this period here. So you can see how easily you can backtest with that library. Now I want to take this to the next level by using some more advanced technical analysis, not just a simple moving average. And I also want to use data that is not just the Google data from this backtesting.test module here. And for that, we're going to need 2 external libraries that we have to install. So we're going to open up the command line and we're going to install, first of all, the pandas data reader. So pandas-data reader, like this. And we also need TA-lib, so the technical analysis lib. Now you can try to just install it using pip. However, it is sometimes a little bit more complicated and you need to pick a specific wheel file, which is why I would recommend that you just watch my technical analysis TA-lib tutorial on this channel for the installation. You can also just Google how to install TA-lib. It's written like this, TA-lib. You can install it however you want if it works for you, but chances are it will not work flawlessly, which means that you have to do some more sophisticated installation. But yeah, those are the 2 libraries that you need, TA-lib and pandas data reader. TA-lib for the technical analysis indicators, which are, by the way, super compatible with backtesting. And we also need pandas data reader to get some data from the Yahoo Finance API. So let's get rid of this strategy here, and let's also let's get rid of everything here. And let's define a new strategy, the MyMACD strategy. Now, I forgot actually what MACD stands for. It was something like convergence, divergence, moving average, convergence, divergence. Was it something like that? I'm not sure. But we pass to this strategy. We inherit from the base strategy of the backtesting module. And now what we're going to do here is we're going to say, first of all, we need to say at the top here, import TALib. And I'm also going to say import pandas data reader as web. And we're going to say now the init method is going to do the following. We're going to say price equals, again, self data close. And we're going to say self MACD is equal to self I. And here we're going to pass now a lambda expression. Let me just zoom in a little bit here. We're going to pass a lambda expression that takes a parameter x. And what this is going to give us is we're going to say talib, so talib dot macd of x. And we're going to pick the index 0. The reason we do it like that is because if we would have a separate function for the MACD and for the MACD signal, for those of you who know a little bit about technical analysis, those are the two things that we need here, the MACD and the MACD signal. Basically, the MACD is just the exponential moving average of the price, considering 12 days, and subtracted by the 26 exponential moving average of the price. Or you subtract the 26-day moving average, exponential moving average from the 12-day exponential moving average of the price. That's the MACD, and the MACD signal is the 9-day exponential moving average of the MACD itself. And if you have two separate functions, what you would be able to do is you could just say talib.macd and then talib.macd signal and nothing else. But since the MACD function returns two values, one the MACD and two the MACD signal, you need to get the results. You need to get the specific index, the specific position of the output, which is why we use a lambda expression, because we need to pass to this I function here something where we just input some data and get one result, which is why we use a lambda expression. So lambda x, again, talib.macd of that data that we pass, and from that we want to have the first result, which is the MACD. If we pass 1, we get the MACD signal. 0 is the MACD result, and we want to apply this on the price. So we copy this now, and we say MACD signal is going to be the same thing, just with a 1 in here. So that works. And then we're going to say the next method is going to be if crossover self.macd, self.macd signal. We're going to buy and elif crossover self.macd signal, self.macd. That is going to lead to us selling. That's a very simple strategy. Again, I have a bunch of videos, not selling, sorry, sell. I have a bunch of videos on algorithmic trading strategy and on building trading bots based on strategies like this one, where I go more into detail on how these strategies work. But here we're going to focus now on the backtesting. So having that strategy, what we're now going to do is we're going to say that we want to have some data. So the data is going to be equal to web.dataReader, and we're going to pass here, for example, the Tesla stock. So TSLA is the stock ticker for Tesla. We're going to get it from the Yahoo Finance API, and we're going to specify for that we need to import datetime SDT, core Python module. We don't need any installation here. We're going to say that the start date is going to be DT datetime 2020, 1st of January, and end is going to be DT datetime 2022, 1st of January. So we have 2 years. We want to backtest. So we get that, we pass start, we pass end, and this is now our data with open, high, low, close, adjusted close, and volume. And we're going to take that and say backtest equals backtest. We're going to say the data is what we're going to test on. The strategy is the MyMACD strategy. The commission is still going to be 0.002, and exclusive orders is going to be true here as well. And then we're going to say stats equals, or actually let's just print it right away. Print backtest dot what was it? Backtest.run. And then we're going to say backtest.plot. And if we run this now and we didn't make any mistakes, we can see that we have this here. So this is the Tesla stock from 2020 to 2022, 1st of January. And yeah, we can see we made a bunch of profitable trades, a bunch of unprofitable trades. But what we can see is that we actually would have lost money with this strategy. So you can see negative 29%. But if we just buy and hold, we would have made 1,128% profit, which is a huge contrast. So if you use that strategy, you would have bought at times where you shouldn't have bought, probably. I don't know, where did we lose a lot of money? Here we lose money, here we lose money. So we bought and sold at very bad moments in time. And just buying in the beginning and holding until the end would have meant a lot more profit. So you can backtest all sorts of strategies on all sorts of data. So we can change this here to be Apple stock, and then maybe, oh, actually I mistyped here. And then maybe you would see that this strategy performs very well. And of course, those are very simplistic strategies. So in this case, what we get here, we have 18%, no, buy and hold is still better. But you can play around, you can make, you can design more sophisticated and complex trading strategies, but you can easily backtest them like that. So you just define what to do, you initialize the individual values, you define with each step what should be evaluated, what decides whether you buy or sell, and then you just pick a data set and you see, okay, what happens with this strategy? Would I lose money or would I make money in that time period? Of course, as always, don't forget that this doesn't mean that anything in the future will work. By the way, all of this is not financial advice, so this is just showing you how to backtest. Doesn't mean that, for example, if you have a strategy that would make, I don't know, 2,000% return in that time period with a particular data set, that this will also happen in the future with other data. Doesn't mean any of that. But this is how you can backtest your stock trading strategies in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in our next video and